Okay, when we talk about a function, so we are dealing with the domain and also range. So what is the domain? So domain is a set of x values, or it is denoted as a capital D and small f. And then what is the range? Range is a set of y values. So let's say if you have this axis, so this is referred to the values of domain or df, and a set of y values, we call this one as a range or rf. So this is domain and range. If x is the domain of f, if x is in the domain of f, fx is defined. Meaning that when you can substitute x inside the function, so let's say we have this function fx is equivalent to x plus 2. So when you substitute x is equivalent to 2, so you will get f2 is equivalent to 2 plus 2 is equivalent to 4. So meaning that when you have x is equivalent to 2, the values of y is equivalent to 4. Meaning that this function is defined. Defined means you will get a real number. So when you substitute real number for the x, any values of x, you will get a real number of y. So that is the meaning of defined. The function is defined. And then how can we find out the domain of the function? So there are two ways to determine domain of a function. So the first method is by using algebraical method, and the second method is by using graphical method. So let's look at to how to find out the domain algebraically. So there are few type of function that you might be dealing with. So let's say we have a polynomial function. So what is the example of the polynomial function? Let's say we have linear function, quadratic function, and cubic function. So let's look at to the first example. We have linear function, fx is equivalent to x plus 3. So when you substitute any values of a real number, when you substitute any real number of x, so let's say you substitute x 1000 or 10,000 plus 3, the values of y, definitely you will get a real number. So in other words, you will get, the function is defined, because when you substitute x, you will get a real number of fx or real number of y. So meaning that that function is defined. So when it is defined, meaning that you can have any values of x in the function of linear. Therefore, the domain of the linear function is from negative infinity until infinity. You can have any negative number or you can have any positive values. Or when you have in terms of quadratic as well, so when you substitute any values of x, the function is defined because you will get real number of y. Fx is, we know that fx is equivalent to y values or the range. So the function you will get y values, or the y values you will get a real number, meaning that the function is defined. Or when you have a cubic function, for example here we have 2x cubed plus 1. So you can have any values of x. When you substitute x, you will get y values, which is a real number. Therefore, for any polynomial function, the domain is from negative infinity until infinity. Okay, that is for the polynomial function. What if you have odd of the root function? For example, we have cube root. So cube root of, let's say we have cube root of x plus 2, or fifth root of x minus 5, or you have 7 root of x plus 1. So all of this root is in terms of odd number. So when you have any root of odd number, let's say if you substitute x, let's say if you substitute x is equivalent to negative 10 inside this function, cube root of that function. So f of negative 10 is equivalent to cube root of negative 10 plus 2. So you will get is equivalent to cube root of negative 8. So when you try to check by using your calculator, cube root of negative 8, so you will get real number, which is negative 2. So that is the values of cube root of negative 8. So in other words, even though the values inside the cube root is negative, you still get the function, you still get the values of y real number. Or in other words, that function will be defined. But let's say you have cube root, same goes when you have fifth root or x minus 5. For example, we have 5th root of x minus 5 or 7th root of x plus 1. So in general, when you are dealing with any odd root of function, even though the values will be negative inside the root, the function is defined. It is not same like when you have even root function. For example, you have fx is equivalent to square root of x plus 3. Okay, just now for the odd root of function, so in general, the domain of any odd root of function, it is from negative infinity until infinity. But for the even root of function, for example, we have square root of x plus 3, 4th root of x cubed minus 27, or 6th root of 25 minus x squared. And we know that when you are dealing with the root of even number, the values inside the root, the smallest must be 0. Other than that, if you have root of, let's say, negative 1, negative 2, square root of negative 1, square root of negative 2, definitely you will get complex number. So we have learned about complex number during the last subtopic. So any even root of negative values, you will get complex number. So when you get complex number, meaning that the function is not defined. Why? Because the function is defined when you get the values of fx2 is a real number. So when fx2 is not a real number, when you substitute any values of x, meaning that the function is not defined. When it is not defined, you cannot include that values as part of the domain. So in general, when you are dealing with any root of even number, the function is in general, so square root of x. So in general, when you have square root of x, the function inside the root must be greater than or equal to 0. So that is the smallest values, or you must have positive number inside the square root. Barulah function 2 is defined. Barulah you will get the fx2 as a real number. Okay, so for example, in this case, our function is not x. So our function is linear. The function inside the square root given is linear, which is x plus 3. Therefore, x plus 3 must be positive values or 0. Therefore, when you try to rearrange, we put x as a subject. So you will get x must be greater than or equal to negative 3. So as a conclusion, the domain for this function, it must be close bracket negative 3 until infinity. Okay, let's say when we try to substitute x with negative 4, which is the values not inside this function. So when you substitute x negative 4, what happened to the whole function? Negative 4 plus 3 square root. See, you will get negative square root of negative 1. Definitely this one is a complex number. So the function is undefined when the values of x is negative 4. So it is proven. So the smallest values that you can have inside the function, inside this function, to make the function defined is negative 3 or more than that. So that's why negative 3 until infinity. So same goes to when you have 4th root. So 4th root, you have square root, you have 6th root. So the properties is the same for all the even root. So our focus is just want to know what is the function inside that root, inside that even root. For this case, the function inside the root is x cubed minus 27. So x cubed minus 27. So the values of x, you will get x must be bigger than equivalent to 3. So we have here x must be bigger than equivalent to 3, because when you substitute, let's say you substitute 3 power of 3, you will get 27. So 27 minus 27 is 0. So 0 is the smallest values that makes the function defined. So the domain is from 3 close bracket until infinity. And the next example here, we have 6th root of 25 minus x squared. So we are just concerned about what is the function inside that even root. So in this case, our function is 25 minus x squared. So that function must be bigger than equivalent to 0. So when you try to solve, so now you are dealing with inequality for the quadratic. So how to solve inequality for the quadratic? You can also rearrange. So you will get x squared we move to the other side, so you will get x squared minus 25, so it should be less than or equivalent to 0. So x minus 5, x plus 5 less than equivalent to 0. So if you try to use the graph quadratic graph method, we have negative 5 and 5. So since it is less than, so the answer should be close bracket negative 5 until 5. So this is another way lah, by using if you try to rearrange, try to make the function, the a become positive, so it will become less than or equals to. So by using quadratic graph, you should get the same answer as by using sine table. So that is the third type of the function. So the first one tadi we have polynomial. The second one we have odd root of function. The third one when you are dealing with the even root of function. So let's look at to the next type of function. Okay, so the next type of function when you are dealing with the rational function. So for each type of function, the way how you find out the domain definitely is different because we want to find out a set of x values that makes the function defined. So of course, different type of function, you are dealing with the different ways to get the domain. So for example, we have rational function here. Any rational function from the equation, I have told you that you have to make sure the values of denominator cannot be 0. So this is what I want to stress here. So denominator cannot be exactly 0. Whatever values that makes the denominator 0, you need to exclude that values in your final answer in equation. So same goes to when you are dealing with inequalities. So inequalities pun sama. So we still need to exclude nilai yang menyebabkan denominator tu 0. So in this case, in general, when you have the rational function in general 1 over x, so this is the simplest function lah dalam bentuk rational. So 1 over x. So x cannot be, so the values of x cannot be definitely 0. So your domain can be all real number except 0. So how can you write down in terms of interval notation? Negative infinity until 0, union 0 open until infinity. So this is when your function is 1 over x. What if your function 1 over x minus 2? You still can have 0. If you substitute 0 inside this function, 0 minus 2, they define. So our concern is the function inside the function in your denominator is x minus 2. Therefore, x minus 2 ni yang cannot be 0. So, x cannot be 2 because 2 will make the denominator become 0 now. So, your domain now is negative infinity until 2, open union 2 until infinity. And then the next one, what if your denominator is quadratic? So, the method is the same. So, if you understand denominator cannot be 0, whatever function given in your denominator you can solve. You can get the domain correctly. So for this one, x squared minus 9 cannot be 0. So the values that makes your denominator 0 is 3 and negative 3. So how can I get 3 and negative 3? By factorize this quadratic. So you factorize x squared minus 9. So you will get 2 zeros here, which is 3 and negative 3. Therefore, x cannot be plus minus 3. Therefore, the domain is negative infinity until negative 3, union negative 3 until 3, union 3 until infinity. So, dia ada panjang sikit lah. The interval will be longer because there are two restricted values of x. And then the next one, you are dealing with the cubic. So, kalau kita congak pun, your cubic, your denominator ni, the only values that makes your denominator 0 is 2. Betul? Because 2, you cubekan 2, you will get 8. So, only nilai 8 will make your denominator become 0, right? Therefore, x cannot be 2. So, the domain is negative infinity until 2, union 2 until infinity. So, that is the fourth type of function, how to get the domain for rational function. And for the last one, it is also possible for you to have even root in denominator. So, if you have even root in denominator, kalau tadi, if you have just even root, for example, you have square root of x. Square root of x, how to get the domain? X must be bigger than equivalent to 0. Now, bigger than equivalent to 0 meaning that you can have 0 inside the square root. But, if you have your root, your even root tu in your denominator, 1 over square root of x. So, square root of x tu dah berada kat bawah. And, just now, we learn about how to get the domain for the rational function. denominator always cannot be exactly 0. Therefore, for this case, when you have fx equivalent to 1 over square root of x, kalau square root of x only, you can include 0 as a domain. Now, since it is in your denominator, we need to exclude 0. Therefore, the domain for even root at denominator, x must be bigger than 0. Another example, let's say we have 3 over fourth root of x plus 2. So since your x plus 2 is in your denominator and it is even root, so x plus 2 must be bigger than 0. Therefore, x must be bigger than negative 2. Therefore, domain is open bracket negative 2 until infinity. So same goes to this one. 6 root of x minus 4. So x minus 4 tu must be bigger than 0. X must be bigger than 4. Itu kalau your even root tu at denominator. So the denominator is in terms of even root. What if your denominator is in terms of odd root? Contoh, you have 1 over cube root of x. What is the domain of this function? So definitely the domain is all real number. Why? Sebab untuk cube root itself, untuk root of any odd number, the domain is from negative infinity until infinity. So whatever values of your cube root, walaupun dia berada pada rational function, So for this one, what is the values that makes denominator become 0 only, you have to exclude. So for this one, your domain for 1 over cube root of x, so x2 just cannot be 0 sebab dia berada kat bawah kan. So in other words, untuk 1 over cube root of x, so the domain is from negative infinity until 0 union 0 until infinity. So when your cube root tu in your denominator, you just have to refer to the rational function punya domain. So let's look at to the exercise after this for you to understand clearly how to find out domain algebraically. Okay, basically finding the domain of a function is important topic. So especially for the engineering student lah and also in ENCS. So you will find out the topic about finding the domain of a function in chapter 4 juga dalam tajuk log and exponential. So make sure you understand well the concept of how to find out domain for the different type of function. The first one we have polynomial. For the even root, how to find out the function, how to find out the domain. And then for the even root function, for the even root function at denominator or the rational function. So we have only 5 types of function. So the way how to find out domain for each type of function are different.